Greetings and welcome to a recorded video in the topic of electric circuits. I hope this video will give you guys an overview. It's just a summary of the topic electric circuits. Yeah, and I think that's it. So I'll try by all means to try and break it down to you so that you can understand it. So, when we're speaking about electric circuits, what are we referring to? So, in the aspect of electric circuit, what we are mainly concerned about, we are concerned about this illustration. So, when we refer to an electric circuit, this is what we're concerned about. We are concerned with this illustration where we have different components in it. So, the first component that we have what we refer to as a switch. Why am I mistaking that? Okay, we are referring to a switch. So, there are two instances of a switch where it can either be a closed switch, like in the illustration, or either be an open switch. So, if you have an open switch, that means that or there are no electric charges that are being transferred, or there are no electric charges that are being moved in that specific electric circuit. However, if it is a closed switch, that means or there are electric charges that are moving in that specific electrical circuit. So that's the first component we're concerned about. The second component, which is very crucial or a very crucial component in terms of electric circuit, is what we refer to as a battery. However, before you can have a battery, you have what we refer to as cells. So cells are something of this nature. You can have this illustration where you have the shortest line, which is the negative terminal of the battery, the cell, and the longest line, which is the positive terminal of the battery. So, this is referred to as a cell. But if you have multiple of these, you have what are referred to as a battery, something like this. Multiple of cells form what are referred to as a battery. I hope you guys understand. So, I say, a battery is a very crucial aspect in terms of electrical circuits in the fact that it is the one that provides energy for the electric charges to flow in that specific circuit and for you to be able to have any form of energy. So, a battery have what are referred to as potential energy. So the potential energy that the battery has is the one that pushes the electric charges for them to be able to flow through around that specific circuit. So, when the circuit is complete and connected, like in this illustration, there will be electric charges that are flowing. Matter of fact, because what? There are batteries, and second, because what? The switch is closed. But in instances where the battery is not available, there would not be any electric charges that will be flowing because why? The battery provides energy for the electrons to be pushed or for the electric charges to be pushed. But if you do not have the battery, there will be no any electrical charges that will be flowing. So the most crucial aspect in terms of a battery is that the battery has potential energy that can be converted to electrical energy for the electrical charges to be transmitted and for them to be able to flow through around the circuit. So that is why I say that a battery is a very crucial aspect in terms of an electric circuit. Okay. And then you have what we refer to as an ammeter. So an ammeter is a instrument that measures the flow of current. But then we'll focus that on greater detail as this video goes on. And then you have what we refer to as a resistor. So a resistor can include anything that uses electricity. Can either be a heater, can either be a fridge, anything that uses energy or that uses electricity in it. That will be referred to as a resistor. And then you have what is referred to as a voltmeter. So, how is a voltmeter different from an ammeter? So, a voltmeter measures the potential difference, whereas an ammeter measures the current. But then you'll understand what is meant by potential difference and current as this video goes through. So, these are the crucial components when we talk about an electric circuit: a battery that provides energy, an ammeter that measures current, a voltmeter that measures potential difference, a resistor that resists the flow of current or the flow of charge, and a switch that determines whether or not electric charges can be flowing or not, depending on whether or not the switch is open or it's closed. So that is what you need to know. And then you continue. As I said, there's something referred to as potential difference. So, what do I mean when I say that something is referred to as potential difference? So, potential difference is another word for voltage, another used word for voltage. So, it's crucial for you to be able to know the definition for exam purposes of what is meant by voltage. So, voltage refers to the work done per unit charge or the energy transferred per unit charge. So, if they say work done or energy, just know that they're referring to one and the same thing, and it always measured in joules. So, if they say what is the potential difference, they're mainly asking what is the voltage of the specific conductor, or what is the voltage of the specific battery, or what is the amount of energy transferred per unit charge. So, when they talk about potential difference, in simple terms, they are referring to how much energy is given to each charge as it moves through a circuit. I said, the electric charges need some form of push for them to be able to move around the circuit, but they cannot move if there is no form of force, and the force relies on the energy provided by a specific battery for them to move. So, potential difference is like the amount of energy to push a specific electric charge in a specific electrical circuit. So, potential difference, also known as voltage. What is the unit or the symbol of potential and potential difference of voltage? So the symbol for voltage is also referred to V, and also keep in mind that the potential difference or the unit for potential difference, it is also referred to V. This is different from other aspects like current, where the symbol is I but the unit is A, which is amperes. So in terms of voltage, remember, symbol always found in what? In the formula V. Whereas the unit for potential difference, it's also V, short for voltage. So you avoid writing the whole term like voltage, so you just shorten it to writing V. So, how do you go about calculating voltage in a given instance? As I said, voltage or potential difference is the what? Is the work done per unit charge. So if they say per, just know that it's always about dividing or division. So the work done, also known as the energy, divided by what? Divided by charge. So the formula to calculate voltage would be V is equals to work done divided by Q. So W refers to the energy transferred, or the energy used by the charges to transmit, to work around the circuit, or also known as the what? The work done. That is what referred to as W in the formula. And Q refers to the charge. As you've done electrostatics previously, you know that Q refers to a charge. That is the complete formula to calculate potential difference in instances where you're given what? You're given the work done and you're given the charge. So, an example where they're gonna say, this is an example. So, if they say that if 2 coulombs of charge transfer 6 joules of energy to a resistor, and they say that calculate the potential difference. So, how are you going to go about with calculating the potential difference? I always say to you guys, it's crucial for you to be able to collect your data. So, you're going to collect, do you have V? You don't have V. That's what you're looking for. Do you have W? Yes, you do have the W, or the work done, or the energy, which is what? Which is 6 joules. And you do have the coulombs, or the charge, which is what? Which is 2 coulombs. Please keep this in mind, that the charge is always in coulombs. And I made an illustration in electricities that if you're given nanocoulombs, you always convert them to coulombs in this aspect of electric circuits. And in terms of joules, the energy must always be in joules. It must never be in kilojoules or whatsoever for you to get a correct answer. It must always be in what? In joules. So how are you going to go about it calculating this? So the V is equals to W divided by Q. V is equals to 6 joules of energy divided by Q, which is 2. Therefore, that means that the potential difference in a specific resistor, or the potential difference which is referred to as the work done per unit charge, is what? Is 3 volt. That is the voltage or the potential difference. That is how you use the formula in instances where you're given work done and you're given charge. So, And then you move to the second aspect of an electric circuit. I said that in an electric circuit, you have what are referred to as a voltmeter. So this would be a voltmeter. A voltmeter is always parallel either to the resistor or to the battery. So let's say, for example, you have this as R1, which is the resistor. The resistor is parallel to the voltmeter in this instance, always parallel. The reason why, it's because current cannot flow through a voltmeter, but it can flow through the ammeter. I don't know how, but yeah, it cannot flow through a voltmeter. So, what is referred to as a voltmeter? A voltmeter refers to an instrument that is used for measuring the potential difference between two points in an electric circuit. So the voltmeter will measure how much energy is being transferred per charge in these 2 points between this specific resistor. That is the main crucial aspect in terms of a voltmeter. So, when the charges are flowing through the circuit, they move through this resistor. They would flow through this resistor. And in the aspect where they flow through a specific resistor, for example, a fridge, and they transmit electrical energy. So as they are transmitting electrical energy, the charges in this aspect of a resistor, they will happen to lose that form of electrical energy. Because why? I said, a resistor, it resists the flow of charge. So once the electric charges reach this specific resistor, they would then slow down. Meaning what? Or they are losing energy. As they are losing energy, the energy then taken by the resistor, and the energy would then be either be converted. Let's say, for example, you have what we refer to as a light bulb as a resistor. So as the electric charges are flowing in the specific circuits, they are flowing around the circuit. They're gonna flow to the resistor, which is R1. Because R1 is a resistor, it will resist the flow of electrical charges. Matter of fact, there will be energy that will be lost in this aspect of the specific resistor. And as there is energy that is being lost, the charges will then continue flowing, but then they will flow at a slower speed or whatsoever, because they've already lost energy to flow in a specific resistor. So the energy that was lost in that specific resistor, it's merely what you're concerned about in the aspect of resisted, the energy that was lost by the electric charges as they were flowing. And then as I said, as the electric charges are losing energy, the energy that is then lost in this aspect of a resistor will then be converted to either be what? Being light energy because we're concerned with the light bulb, or being heat energy because we're concerned with the heater or whatsoever. But then remember, the energy cannot be formed or cannot be destroyed, but can only be what? Be converted. So the energy which was potential energy initially, but then became electrical energy and then flowed through the electric circuits and then reached the resistor, would then convert from being electrical energy to being what? To being either heat energy or being light energy, depending on the type of resistor that you have. Please remember, I say, when you're concerned with resistors, what are resistors? Resistors can be anything that uses electricity. Can either be a fridge, can either be a heater, can either be a light bulb, or anything. And I say, if they ask you, define what is a resistor. A resistor refers to an aspect that resists the flow of charge. Let's say, for example, you are pushing a trolley. As you're pushing this trolley on a flat surface, you then happen to reach a carpet. The carpet will serve as a resistor in this instance, in that it resists the flow of charge. The trolley would represent a charge, and as it is flowing, there's flow of charge. But once it reaches the carpet, there's some form of resistance. The charges are then now facing some form of difficulty for them to move. That is the main aspect concerned with resistors. Resistors resist the flow of charge. So as the carpet resists the trolley from flowing through, there's some form of energy that is being lost. And as that form of energy is being lost, the energy that is being lost will then be converted to accommodate the specific resistor that you have. As I said, you have electrical energy, and as there is flow of charge and they reach the specific resistor, the electrical energy would then be converted to either heat energy or light energy, depending on the type of resistor that you have. That is only example I can think of right now when it comes to resistors. So always remember what resistors, either light bulb, either a fridge or whatsoever that uses electricity, resist the flow of charge. And as it resists the flow of charge, there's some form of energy that the electrical charges will lose, and then the energy in that aspect will be converted. That is what the aspect of resistor is concerned about. So I said, when we're talking about voltmeter, the voltmeter in this instance will be the one that will measure the energy that was lost by the charges in this instance. That is what the potential difference in the aspect of a resistor. Okay, so I want you to remember this in the certain instance where they're going to ask you in the exam, where they say make a difference between EMF and potential difference or terminal potential difference. So the main crucial aspect is whether or not it's an open circuit or a complete circuit or not a complete circuit. So when they talk about EMF, what are they referring to when they refer to EMF? So EMF is the potential difference across the terminals of a battery. Let's say, for example, you have this battery here. As you have this battery, this is terminal, the positive terminal and the negative terminal. And they say, for example, they put an illustration in the question like this. V, and then you have something like this. And they say, what is the voltage? The voltage in this instance is because it's not a complete circuit, the circuit is not complete. The potential difference in this aspect will be whatever voltage that specific battery has. So, in simple term, when they refer to EMF, they refer to maximum energy that a specific source can provide. Let's say, for example, a battery can provide 24 volt of energy, or 24 volts of energy for the electrons to be pushed, or for the electric charges to be pushed. That is what referred to as an EMF. This is not a complete circuit. The circuit is not complete because there aren't any other components of an electric circuit. So when they say EMF, they're mainly talking about the potential difference across the terminals of a battery. That is not a complete circuit, but the EMF of a battery, what is the maximum amount of energy can a specific source apply? In this instance, this battery can apply or can provide a maximum amount of energy, which is 24 volt. That will be the EMF. No matter of fact, not a complete circuit. That is what you need to know. Okay, and then this is different from what? From terminal potential difference. And that in a terminal potential difference, there will be what? There will be a complete circuit. That is what a terminal potential difference is distinct when it comes to EMF. So let's say, for example, you have this illustration. And then they say this is the switch, and then let's say, for example, this is the resistor, and then this is an ammeter, whatever. And they say, worry, calculate the potential difference. In this instance, you will not be concerned with EMF, but you'll be concerned with terminal potential difference. Terminal potential difference, because why? It is a complete circuit or a closed circuit. Terminal potential difference. So you need to be able to differentiate between EMF and terminal potential difference. Okay, so if they ask you a question in the exam, define the term potential difference across a conductor. That is the work unit or the work done or the energy transferred per unit of a charge. But in terms of EMF, it's one and the same definition, but then you're going to say that in terms of EMF or it is the work done per unit charge in a battery or in a source, or the energy transferred per unit charge in a specific battery or specific whatsoever. That is the difference between EMF and potential difference across a conductor. So you must be able to distinguish between EMF and terminal potential difference. In that in EMF you're concerned with what? Not a complete circuit or not a closed circuit, just only this aspect of a battery. And then when we're talking about terminal potential difference, we're talking about the potential difference or the energy transferred throughout the whole circuit, concerned with a complete or a closed circuit. Okay, if you have any questions, you're allowed to send me them via WhatsApp and whatsoever. So the first aspect of an electric circuit, you're very concerned about it. And then the second aspect that you need to remember, that you need to know, that is crucial for you to know, you need to be able to know the aspect of current. So when they say current, what are they referring to? So the proper definition for current for exam purposes is that current is the rate at which charges move past a fixed point in a circuit, or it's the what? The rate of flow of charge. So, the example that I can use is that, let's say, for example, you have water and water is flowing through a specific pipe. So, as the water is flowing through that specific pipe, the water will be regarded as electrical charges that are flowing in a specific electrical circuit. So the water will be regarded as the electric charges. And as the water are flowing in that specific electric charge, they flow at a specific rate. No, they move past a certain point at a specific time. So that is what current is concerned about. How many charges are moving through a specific point at a specific time? Matter of fact, hence the definition rate flow of charge. These charges are flowing at this specific point at this specific time. So the proper definition that you're going to use for 2 marks is this one. The rate of flow of charge, they talk about current. The rate, not rate, but how many charges are flowing through this specific point at this specific time. That is what current is concerned about. And the unit for current is what? Firstly, the symbol, as I said, symbol is the word or the sign that is used mostly in the formulae for a specific aspect. So the symbol for current would be what? Would be an I. But for the unit, it'll be A, or also referred to as amperes. You cannot write amps, as in instances you will be marked wrong. So these are the two wordings that you need to use, either A or amperes in 4. So as I said, current is the rate of flow of charge, meaning what? How many electric charges are flowing at a specific point in a specific time. That is current. And the formula to calculate current is which one? So for you to be able to get current or the rate of flow of charge is using this formula. I is equals to what? Q divided by change in time. Hence the definition. Q, flow of charge. Rate refers to what? Refers to the time. Always measured in what? Always measured in seconds, and the charge always measured in coulombs. Don't mistake that. If they give you what are the time at which specific charges are flowing in that specific point, they give you it in minute. Always be able to convert it into seconds, because if you don't convert it into seconds, you're gonna get it wrong. You're gonna be marked wrong. So it's crucial for you to be able to convert it into seconds and whatsoever. That's it. And then, so when current flows in a circuit, or when there's a flow of current in the circuit, the illustration to show how there's current flowing, we use arrows. So let's say, for example, you have an illustration of this nature. Let's say you have the battery and you have your electrical circuits and whatsoever resistor, you have a closed switch, and yeah. So to show current, which direction is the current flowing to? Remember, in the aspect of a battery, just know what a current will always flow from the positive terminal to the negative terminal. And I said, the positive terminal is the longest part of the battery, whereas the negative terminal is the shortest line in the battery. So that means what a current will flow from this aspect, which is the positive part. So it will flow from this direction, in this direction, in this direction, in this direction, until it reaches back to the specific battery. So the charges would flow from the positive terminal up until the negative terminal. That is where the current will flow through, or the direction in which the current will flow in. And in the illustration that I've made initially, I said you have what we refer to as an ammeter. So, an ammeter is distinct from a voltmeter in that voltmeter measures the potential difference or the energy transferred per unit charge. Whereas in the aspect of an ammeter, it is an instrument that is used to measure the rate of flow of charge, or an instrument that is used to measure the flow of current. To measure the current, okay. these amount of charges are flowing in this specific point in this specific time. That is crucial. That is what an ammeter is there for. So an ammeter, in simple term, measures how many charges are flowing through a specific point. I don't know if you can see my handwriting. At a specific time. That is what an ammeter is concerned about. Measures the current. Simple term, it measures the current. Simple. Okay. As I said, you have what? You have current, which is the rate of flow of charge, or how many charges are flowing in the specific point at the specific time. That is current. And what? The symbol is I, capital letter I, and the unit is what? Capital letter A, or also known as amperes. And you have what is referred to as voltage or potential difference. I said that you must always make a differentiation between EMF and terminal potential difference. Okay. Voltage, always measured in volts, or V. The symbol is the same as the unit in the aspect of potential difference or whatsoever. Okay, and then the formula to calculate voltage, I say that the formula to calculate voltage is V is equals to W divided by Q, which is the work done divided by the charge. And then the formula to calculate current is I is equals to charge divided by the time, which suffices the definition of rate of flow of charge. Simple. And then I made an illustration in terms of resistors. I said that a resistor can either be anything that uses electricity. It can either be a fridge, can either be a heater or whatsoever that uses electricity. Okay, and I said that the definition of resistor is something that resists the flow of charge. So in the aspect of resistors, I made an example of a trolley in that you have a trolley, and then if you push it through a carpet, the carpet will resist the flow of that specific trolley. The carpet will resist the flow of that specific trolley in that it'll then lose some form of energy, the one that was flowing in initially, and then there will be energy lost. And then the energy that was lost will then be converted to accommodate the type of resistor that you have. And that will be the end of the aspect of resistors. Okay, so how do you use the formula I is equals to Q divided by time? Let's say, for example, they say an amount of charge equals to 45 coulombs. Charge equals to 45 coulombs moves past a point in a circuit in 1 second. And they say that the time is 1 second. And then they say calculate the what? Calculate the current. Remember the definition of current, rate of flow of charge, or in simple terms, how many charges are flowing through a specific point at a specific time. And in this illustration, they said 45 coulombs or 45 or charge, coulomb of a charge are flowing through a specific point in 1 second. And then the formula would be I is equals to Q divided by change in time. I is equals to 45 divided by 1. Therefore, that means that your current or the rate of flow of charge in that specific point in time would be what? Would be 45 A, or also known as amperes if you don't want to write the capital letter A. So that is how you go about it, the formula of I is equals to Q divided by change in time. Okay, so the second aspect that you need to know in terms of electric circuit that is very crucial is the calculation part. So in electric circuit, I said that you have resistors which resist the flow of charge, number one. So we have what are referred to as the resistors in series and resistors in parallel. So resistors, the unit for resistors is what are referred to as ohm. Ohm. That is the unit for resistors. And the symbol for resistors will be I, R. In instances where you're given a formula, you're gonna use R, you're gonna not use ohm. Ohm is the unit, whereas R is the symbol. Do you get that? Okay, simple. Very fair. So I said, you can have resistors in parallel and resistors in series. So the first one is resistors in parallel. Let me write down here. So you have resistors in series. So what do they mean or resistors are in series? So when they say that resistors are in series, they mean or they are following one another. Not like follow, but like they're in, I don't know, I don't have the word to use right now, but like they're following one another. So an illustration of resistors in series can be something of this nature. Let's say you have a battery here, and then you have this resistor here, and then you have this resistor here, and then that will be a complete circuit if you have a switch. So when they say the resistors are in series, they mean the electric charges are flowing and there is no split of they are following in one pathway. So when you move from the positive terminal, let me reduce the font of this so when you're flowing from the positive terminal of the battery, let me make an illustration with so when they say that resistors are in series, they are referring to the fact that they are flowing in one pathway. There is no split in that specific. They are flowing in one pathway. So let's go back to the illustration. So if they say they are in series, you move from the positive terminal and then you move across, you pass R1, you pass R2, you pass through the switch, and then you go back to the battery. By virtue of this illustration, you can see what there was never another pathway where the current had to flow in a different aspect. So, in the context of resistors that are in, so we say that they are in one pathway, and as they are in one pathway, the current remains the same. The same. Meaning what? They mean the current flows in one pathway. There is no division of the current whatsoever. It flows through one pathway until you go back to the negative terminal of the battery. So if you move from the positive terminal of the battery, the current will flow from this side. Flowing current, still moving in the same pathway, flowing current, until it reaches the negative terminal of the battery. So, in terms of resistors that are in series, they are flowing in one pathway, number one. Number two, current remains the same. The current does not change, it remains the same throughout the whole circuit. The current will remain the same. Okay. And what you need to know, which is very crucial when it comes to resistors that are in series, is that the voltage, or also known as the potential difference, is the one that splits, or the one that gets divided, or there's some form of separation in terms of voltage. So in resistors that are in series, the voltage of this R1 will be different from the voltage of R2. In certain instances, it'll be different, but in certain instances, they say that the voltage will be 4 J. I don't know if you can understand, but yeah, the voltage splits. That means the voltage of the battery that is provided by the battery is equal to what? The voltage of, let's say, there's V1 here and there's V2 here. That means the voltage of the battery would be equal to the voltage of V1 plus the voltage of V2, read by V2. So that is the aspect of voltage in terms of resistors in series. Let me explain again. When they say that resistors are in series, I said current remains the same throughout, number one. Number two, the voltage is the one that is splitting, or the one that gets divided. Therefore, that means what? That means that the total voltage of a battery or a specific source is equal to the voltage read by different voltmeters. In this instance, voltmeter 1 will read a different voltage, and voltmeter 2 will read a different voltage, as referred to R1 and R2. Okay, that is what you need to know. In terms of series, current remains the same, but the voltage splits. Okay, in terms of series, what you need to know is being able to calculate the total resistance of a specific electric circuit. So, the formula to calculate total resistance is RT is equals to the resistance R1 plus R2 plus dot dot dot. So the dot 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 refers to the continuation. What do we mean by continuation? When I say that it refers to continuation, it refers to the fact that the depending on how many resistors you're going to include. Let's say, for example, in this instance, you have two resistors. That means that the formula will end here. It will not continue. But if you have more than two resistors in the illustration, the RT would be R1 plus R2 plus RC. That will be the total resistance. So I hope you understand. And then the second part that you need to know is resistors that are parallel. So when we're talking about resistors that are parallel, what are we referring to? So let's say you have an electric circuit of this nature. So as you have this electric circuit, you have, maybe let's say this, and then you have something of this nature. So as you have something of this nature, this indicates R1 and R2, they are parallel to one another. Parallel lines, guys. Mathematics, they are parallel to one another. So, in the aspect of them being parallel to one another, that means the resistors, they are not using the same pathway as compared to resistors that are in series. They are flowing through the same pathway. But in terms of resistors that are parallel to one another, they are not using the same pathway. So what am I referring to when I say that they are not using the same pathway? Let's make use of an illustration. So, from where the current flows from the positive terminal, you pass through the ammeter, it reads the current, and then you reach this part. So as you reach this part, you can see there are two parts, part for R1, part for R2. That indicates there are two different pathways in which the resistors are in. So resistor number 1 is in this pathway and resistor number 2 is in this pathway. So they're in different pathways. That means what? That means the current in this instant is the one that splits or that gets divided. The current will split. As an illustration, you can see how the current is flowing from the positive terminal. It's moving from the positive terminal. It's read by the ammeter. And as it is read by the ammeter, you can see how it's still one in the same pathway. That means the ammeter, always in series, it reads the current in the pathway, the same pathway, before you reach the division of the pathways. So as it moves, the current then reaches this part. As it reaches this path, the current will flow to both the pathways. That means that it will divide. It will not be the same current for both of them, but then the current will divide. So that means that a certain amount of current will move to this aspect, and then another aspect of current will move to this pathway. So a certain amount of current that is unknown will move to the first part of R1, and the another aspect of current will move to the second part of R2. So in terms of resistors that are parallel one another, they're using two different pathways, and as they're using two different pathways, there's a split in terms of what? In terms of current. But the voltage is the same, remains the same. So what am I referring to when I say that the voltage remains the same? The voltage does not divide. So in instances, let's say for example, they say that the voltage of this battery is 2 volts. That means what? That means that the voltage of the battery is equal to the voltage either read by V1, and same to the voltage that is read by V2. Do you get that? So if they say that resistors in parallel, the voltage will remain the same. That means that the voltage that was read by the the voltmeter in this aspect will be the same as the voltage that was read by V1 and the voltage that was read by V2. So in terms of resistors that are in parallel to one another, we say that they're using two different pathways, number one. As they're using two different pathways, or not two, but different pathways, not two, because there are certain instances where you be given three resistors that are in parallel. So they're using different pathways, number one. Number two, the current is the one that will split to the different aspects of the pathways, number two. However, the voltage will remain the same. That means the voltage that you're gonna get for this one will be the same as the voltage that you're gonna get for this one. It'll remain the same because they are parallel to one another. Guys, I don't know if you understand this, but like, let me make an illustration. Excuse me. So let's say, for example, you're given this illustration, and they say that this is R1 and the voltmeter V1, and then this is R2 and the voltmeter V2. So if you have something of this nature, you have two resistors that are using two different pathways, because you can see the current flows, but then it reaches this part with this two different pathways. That means current will flow to this side and current will flow to the side as well. And then they will then meet again in this specific aspect. Let's say, for example, they say that the battery provides an EMF of 12 volts. It provides potential difference or provide voltage of 12 volts or maximum energy of 12 volts. And they say, for example, they say that resistor 1 has 2 ohms and resistor 2 has 4 ohms. So what will happen in this instance? And then they say, hore, what is the voltage of R1? They say, what is V1? What is V1? Hore, what voltage did V1 read? Because they are parallel to one another. V1 is parallel to V2, or R1 is parallel to R2. That means what? The voltage read by V3 in this instance will be the same as the voltage read by V1 and also read by V2, because what, they are in parallel to one another, and there is no resistor that will be either be in series with them or whatsoever. So that means what? V1 is also equal to 12 volt and V2 is also equal to 12 volt, because why? They are in parallel and the voltage will remain the same. It does not split. But what will happen to the current? Because it is a parallel circuit, or resistors are parallel to one another, the current would split to this side and this side. That means that there will be a division or a difference or a split in terms of the current read by the ammeter. Let's say, for example, there's an ammeter here and an ammeter here. That means that those two ammeters will read two different currents or whatsoever. I hope you understand. If you don't understand, please go back and refer to the video previously so that you can get some form of understanding. So that what happens to resistors that are parallel and resistors that are in series. However, in certain questions in the exam, they're gonna confuse you. Let me look for an illustration where you're gonna have where's the question? Where you're gonna have resistors that are parallel. That is a combination of parallel and series in one instance. So let's say you're given this illustration. And they say that this is the battery. And then you have R1. And then, which is 6 ohms. And then you have what? You have R2, which is what? Which is 12 ohms. Let me make a different color for the unit, which is 12 ohms. Okay. And then they say, or you have R3. R3, which has what? Which has also 12 ohms. So this is an illustration. Let me erase this so that it could be clear. Okay, so this is an illustration, and let's say, for example, they say you have a voltmeter this side, V1, and you have a voltmeter this side as well, V2. And then they say, first things first. They say, maybe the question, they say calculate the voltmeter or the voltage that was read by either R1 or R2, depending on the okay. The first question they say, calculate the total resistance. How do you go about calculating total resistance? In the previous example, I said you calculate total resistance. I made an illustration on how to calculate total resistance for resistors that are in series only and calculating the total resistance for resistors that are in parallel only. But in this illustration, you can see there's one resistor that is in series that follows one pathway. And then before you reach this aspect, or when you reach this aspect, there's a split in terms of the pathways. There's pathway number 1, and then there's pathway number 2. So that means what? That means you have both resistors in series and resistors parallel all in one illustration. So if they tell you how to calculate the total resistance, how are you going to go about with it? So the first thing that you're going to do, you're going to calculate the total resistance of a parallel or the R parallel. Yes. The first thing you're going to calculate the R parallel. So how do you go about calculating R parallel? You're going to say 1 divided by R parallel is equals to 1 divided by R2 plus 1 divided by R3. That is an illustration to calculate the formula to calculate resistors that are in parallel to one another. So how are you going to go about it? You're going to say 1 divided by R parallel is equals to 1. What is R2? R2 is 12 ohms plus, what is R3? 1 divided by 12 ohms. So you're going to put it as it is in your calculator. You're going to say 1 divided by RP is equals to 1 divided by 12 plus 1 divided by 12, and you're going to have what? You're going to have 1 divided by 6. And because what you're looking for R parallel, not for 1 divided by R parallel. You're going to say, take what is bottom and give it to the top, and take what is the bottom and take it to the top. So you're going to say RP is equals to what? Is equals to 6, because you've taken the 6, you've put it in the top, and you've taken the 1, you've put it in the bottom. So that means that the R parallel will be 6 ohms. That means the resistance or the total resistance in this series, where in these resistors in which they are parallel to one another, the total resistance or the R parallel is 6 ohms. And then the second illustration, that because you're looking for total resistance, you're not only concerned with R parallel, but you also have R in series, which is R1. So that means that the R that is in series would be what? Would be 6 ohms as well. R series is this one, R1, because it's the only one that will be in series. Unless, let's say, for example, they made an illustration that you have another resistor in here, then you would have made use of the formula RS is equals to R1 plus R2 whatsoever. But in this instance, because there's no other resistor, that means that the R series or the resistor that is in series has a total resistance of 6 ohms, whereas the resistor that is in parallel also has a total resistance of 6 ohms. But you're not only concerned with the resistor or the total resistance of series that are in parallel or series that are in series, but you're concerned with the total resistance of the specific electrical circuit. So how are you going to go about it? So to calculate total resistance, you're going to have RT is equals to what? R parallel plus R series. That means that RT, or the total resistance of the specific circuit, will be the R parallel, which is 6, plus the R series, which is 6. That means that the total resistance in that specific electrical circuit would be 12 ohms. That means that this specific electrical circuit has a total resistance of what? Of 12 ohms. If you combine all the resistors whatsoever using the appropriate formula to calculate. If you don't understand, please go back to the video and watch again so that you can gain a full understanding or an overview of this aspect of excuse me, of R parallel and R series, then calculating the total resistance. So that is the formula to calculate total resistance. So in the aspect, R2 and R3 are the ones that are parallel to one another, but R1 is not parallel to any others. So that means that in this instance, as R1 is not parallel to any other resistor, that means the current from the positive terminal of the battery would remain the same in this whole aspect of this electrical circuit until it reaches this point where there are two different pathways. And as the current reaches the point where there are two different pathways, there will be what? There will be a split in current. Remember, if there are two different pathways, there will be what? There will be a split in current. But in instance, because R1 is not parallel to any other circuit, that means what? That means the current will remain the same as the total current until it reaches this point. I hope you understand. Okay, so in this illustration, you've calculated that the total resistance at whatsoever. Let's say, for example, they, excuse me. Oh, let's say, for example, they say the total voltage of this specific illustration is 24 volt, or the battery can provide 24 volt of energy, and they say calculate the what? Calculate the total current. The formula to calculate total current is this one. V is equals to IR. Or matter of fact, it's up to you. You can use this triangle, which is VIR. Depending on the answer that you on the unit that you're looking for, you're gonna use this formula to your own accord. Can also be found in the answer sheet or the exam pads or whatsoever for you to be able to calculate total current. So by looking at your illustration and collecting your data, you can see you have total resistance of what? Of 12 ohms as you've calculated. That means that the total resistance or the R will be 12 ohms. And the total voltage or the voltage of the entire electric circuit is what? Is given in the illustration. It is 24 volts. But when that is what you're looking for is the I total or the total current of the whole electric circuit, not just specific parts of the electric circuit. So you're gonna say V, not V equals to IR, but you're gonna have what? You're gonna use the formula I. That means what? Because I is here, that means you have I divided by I is equals to V divided by R. Therefore, you're going to have I equals to V divided by R. That means that the total current that flows through the specific electric circuit will be 24 divided by what? Divided by 12. 24 which represents the voltage and 12 represents the resistance. Therefore, I total will be what? 24 divided by 12 will be what? Will be 2 amperes or amps whatsoever. That will be the total current or the current that flows through the whole circuit. But by the look of things in your illustration, you can see I say current in a series or resistors that are in series to one another does not split. That means what? That means that current of 2 amperes would flow from the positive terminal of the battery, pass through R1 because R1 is in series, and in series current does not split. So that means what? Current will pass through R1 as 2 amperes, but then as it reaches this specific point, it will then split. That means that the current will either have current of I1 and I2 and I3. That'll be the split of your current as it reaches the different pathways in that specific illustration. And they say calculate the current of maybe let's say R2 or whatsoever. By looking at your data, you can see, I don't know if I'm confusing you, but I'm trying by all means to simplify. So if they say calculate the current, you're gonna look at your data. Let me erase this so that you can look at the illustration that you have. So by the look of things, you can see R2. In terms of R2, you have what? You have resistance of R2, which is 12 amperes. You don't have the voltage for R2, and you can't say it's 24 volts because why? There's R1 which is in series. Unless if you did not have R1, you could have said that the resistance of R2 is 24 volts because in resistors that are in parallel, the voltage is the same. But in this instance, you do not have only resistors that are in parallel, but you also have ones that are in series. So you're going to have R is equal to 12 amperes, V, you do not know, I, which is the current, which is what you're looking for. So how are you going to go about with getting the current in this instance? For R2, you do have the total current, but you cannot say I1, I2 or I3 is 1 or 1 ampere, 1 ampere each, because they never said that they divide. They say that it splits, but not divide. So how are you going to go about it? Because you have total voltage or the voltage of the battery, which is 24 volts. Different aspects will use different voltages. And as R1 is in series, it'll have its own voltage because what? In terms of resistors that are in series, the voltage splits. That means what? Or you're going to calculate data. Voltage of R1. R1 has a resistance of 6 amperes and has a voltage which is the unknown. But because it is in series, that means that the total current of the whole circuit, it's similar to the current of the series of the resistor that is in series. I don't know if you understand. If it's in series, the current does not split, but the voltage splits. And a hint, if you have resistors that are in series, the current of that specific resistor would always be the same as the total current of that specific charge. That means that the total current is 2. That means that the current of R1 is also 2. So you can use the formula V equals to I multiplied by R. V is equals to total current, which is 2, and the resistor is 6. That means that the voltage will be what? 6 times 2, which be 12 volts. That means or what? R1 has a voltage of what? Of 12 volts. But that is not what we're concerned about. What we are concerned about is the voltage of R2 for you to be able to calculate the current of R2. So, as the voltage of R1 is 12 volt, R1 as it is in series, that means total or the voltage of the battery would be equal to the voltage read by R1 plus the voltage read by L2 by V2 I meant. And I said if resistors are in parallel, the voltage read by V2 will be the same as the voltage read will be the same as the voltage read by V3. V2, V3, same voltage. That means that the voltage of the battery is what? 24 is equal to voltage of R1, which is what? You got it, which is 12 volt, plus the voltage of V2, always the same as the voltage of V3, because why? They are parallel to one another. Therefore, that means what? That means 24 minus 12 is equal to V2 or V3, same. V2 or V3 would have a voltage of what? 24 minus 12 would be 12 volts. That means that both V2 and V3, as they are parallel to one another, they would have what? They would have the same voltage, which is 12 volts each. Not that you divide the 12 by 2. Each and every resistor that is in parallel would have the same voltage. That means V3 and V2 would read R2 and R3 have a voltage of 12 volts each. I hope you understand. Okay, so since you've gotten the voltage read by V3 and V2 is the same, which is what? Which is 12 volts each. You go back to illustration. The question said, look for the current or the I2. The I2 is the one that you're looking for. But because in R2 you already have the voltage, which is what? 12 volt. And the resistance, which is what? 12 ohms. It'll be easier for you to use the formula I is equal to... Where is the illustration? I is equal to V divided by R, and then you're gonna substitute V, which is 12, R, which is 12, and then it's gonna be 1 amperes because 12 divided by 12 is 2. That means the current that flowed through R2 is 1, and the total current as it is 2. For you to be able to get I3, you're gonna subtract I total is equal to I2 plus I3. And then I3 is the subject of the formula. You subtract from the total current that you have, and then you'll be able to get I3. I hope you guys understand and got an overview of the concept of electric circuits, resistors that are in series, resistors that are parallel to one another, and a combination of resistors that are in both series and parallel. I'll try to make a recorded video of a proper illustration or an example of an exam question where you have a combination of both resistors in series and resistors in parallel, where you have to calculate the current or calculate the voltage or calculate the EMF. In instances where you're going to have to go through the whole calculation, look by the virtue of your formulas or what do you have and what you don't have. And then I'll see you guys on Sunday. Thank you very much. Good night.